So we have a couple steps to solve for Ksp here. So the very first thing we want to do is write out the equation here. So bismuth iodide, when placed in solution, will dissociate into lithium bismuth plus 3 and 3 iodines. So that's our first step. All right, so let's write a quick Ksp expression. Ksp would equal bismuth and then iodine, and then we got to make sure we cube that I because of the 3 in front. We can make an ice chart. These are zeros. Okay, this is going to appear at S. This appears at 3S. So now we can plug this in. All right, so we have S times 3S cubed. We know Ksp is 7.71 times 10 to the 19th equals 27S to the 4th. And then we can solve for S. I'm getting 1.3 times 10 to the negative 5th for S. All right, so that's our solubility, but this is the molar solubility, so we got to convert to grams per liter. Let's take that, and then we'll just say 1 mole, and then we know the molar mass is 589.69, so we just multiply it. And we find out that the solubility in grams per mil is 7.6 or 7.7 times 10 to the negative 3rd grams per liter. All right. Let's look at number 2. So again, first step, write out that equation. So we got yttrium fluoride will break down to Y plus 3 and 3 F minuses. We can write a Ksp. Ksp equals Y plus 3 times F minus to the 3rd. We can make an ice chart. 0, 0, S, S, 3S, 3S. And then we plug everything in. 8.62 times 10 to the negative 21st equals S times 3S cubed. So we get 8.62 times 10 to the negative 21st equals 27S to the 4th. Again, we'll solve for S. And then we're going to raise that, so we get to 4.22 times 10 to the negative 6 molar, and then we're going to multiply that by the molar mass to turn it into grams per liter. So 1 mole has a mass of 145.9. We get 6.16 times 10 to the negative 4th grams per liter, and that's a negative 4. Let's write that again. That's atrociously sloppy. That's 1 and 2. So for the next set of problems, we got the same thing. But now we're going to work backwards. We're going to find Ksp, but it doesn't really change too much. So we've got our salt. Let's figure out its dissociation rate. It's going to form 2M at plus 3 and 3X at minus 2. If that's what the salt would turn into. So we could write, hey, Ksp end up going to be M plus 3 squared times X minus 2 cubed. That's our Ksp expression. Still make an ice chart. All right. that means 0, 0, all right, 2s, 3s. So this is going to be a big one. So now let's figure this out. So KSP equals 2s squared times 3s cubed, or KSP equals 108 s to the fifth. And we know s is the molar solubility, so KSP equals 108 times 2.3 times 10 to the negative third to the fifth power. It turns out the KSP for this is 6.95 times 10 to the negative 12. So let's look at, there's another one. So the solubility product, or the solubility of tin hydroxide is 1.69 times 10 to the 7 grams per liter. We're given a molar mass. We're looking for KSP. Same procedure. All right, nothing new. All right, so we got tin hydroxide. It's going to become tin plus 2 and 2 hydroxides. So we'll do this like this now. Let's do our ice drops. It's right here. So 0, S, S, 0, 2S, 2S. KSP equals tin and hydroxide. All right, so we can do this. KSP equals S times 2S squared. Oh, nope, squared on the outside. So KSP equals 4S cubed. All right, S, right, molar solubility. We don't have the molar solubility yet. We have the solubility in grams per liter. So now we're going to say 1.69 times 10 to the negative 7. So our S is 1.1 times 10 to the negative 9th, and then we can plug that into there. So KSP is 4 times 1.1 times 10 to the negative 9th cubed. .32 times 10 to the negative 27, or that's KSP. All right. All right, so now let's do these ones. So let's rank these salts from least to most soluble. So let's just write out what would that bare KSP expression be. So this salt has 4 ions. Silver iodide has 2 ions. Nickel phosphate has 5 ions, and lead sulfide also has 2 ions. Right. So if we know the ions, right, we really know what we can write the KSP would equal to. So KSP, if there are 4 ions, is always equal, right? 4 ions, right? That's going to end up being sorry, 27 s to the 4th. All right, 2 ions is s squared, and 5 ions is 108 s to the 5th. So now we're just going to take our exponent and divide it. So negative 44 divided by 4 is negative 11. All right, negative 17 divided by 2 is negative 8.5. Negative 32 divided by 5 is negative 6. And negative 28 divided by 2 is negative 14. So which salt is going to be the least soluble? The one that has the smallest exponent. That would be negative 14. All right, and then we're just going to go from there. Then we've got thallium hydroxide. Right. Then we have silver iodide. And then last but not least, nickel phosphate. All right, do the same thing. This last problem. Right. So again, get your counts. How many ions does everybody have? Copper hydroxide, 3. Copper iodide, 2. Aluminum phosphate, 2. Barium sulfate, 2. All right, so what does this equal? All right, so this is 3 ions, 4s cubed, and these are all s squareds. So again, do your division. This is 4s cubed. 20 divided by 3, all right, it's like basically 7. Negative 12 divided by 2, right, that's negative 6. This is going to get you negative 11.5, and 10 divided by 2 is negative 5. All right, so here again, what's the least soluble? The biggest x or the smallest exponent? Aluminum phosphate. All right, and then we're just going to go in order. All right, then we would have copper hydroxide, copper iodide, and barium sulfate.